Hello, my name is Jade and this is my presentation on basic network architecture. In this presentation I'm going to be discussing the different layers and structures within network architectures. Over the next few slides I'm going to discuss network structures, main types of network architecture structures, the layers within the network structure, reference to the OSI layer model, and the TCP model. LAN. Local area network. This is an individual network that typically are small in size and are usually within a singular geographical area, such as within a home or a small business. Wide area network. This is a network that is made up of numerous LAN networks, which are connected together via numerous devices, allowing them to connect and communicate over a number of geographical locations. Internetworks and Internet. An internetwork is a series of LAN and WAN networks that are connected together in a mesh-like structure. The majority of networks are owned by a variety of ISPs and organizations. This is what makes up the Internet. The Intranet is the private connections within the networks which make up intranetwork. Peer-to-peer. Peer-to-peer or P2P, as it is also known, is a network that is made up of two or more computers which have the ability to share resources without the need of a dedicated server. The end device has the ability to act as if it was both a server or client-server. This is where a client accesses services from a server in comparison to a peer-to-peer network where a server isn't used. Internet applications, e.g. DNS, and functions such as email exchange are based on the client-server model. Layer 1. Physical. The first layer is the OSI model, which consists of components that make up a network, such as hardware, like cables and switches. This is a layer that carries the signals needed to communicate with the higher levels of the OSI model for successful communication in the network. Layer 2. Data link. The role of the second layer is to look for errors during transmissions from the first layer. It also manages addressing and deals with network device access. There are two sub-layers, the first being media access control and the other being logical link control. The data link layer also deals with segmentation and bit ordering. Segmentation is where packets are made into a suitable size for transmission. Bit ordering is the organization of data bits into frames before the transmission process. This is where the bits are ordered as well as other functions such as parity occur. The purpose of parity is to check that all data that has been sent has been received successfully by the destination. Layer 3 network. Layer 3 of the OSI model is the network layer. The main roles of the network layer are to work out network types, routing, and the representation of data before the transmission process and the encapsulation of transport data. Layer 4. Transport. The transport layer is both within the OSI and TCP model. This layer provides services such as flow control. The transfer layer resembles data, can detect errors, and if there's any data loss, including information for recovery of data, such as the transmission of data. Due to a lot of network traffic, data can be easily lost. The transport protocol would be used in order to use a checksum to detect if there are any errors. Flow control is a function that's used between two nodes in order to stop too much data being transmitted at one time, making it a more efficient process. Layer 5. Session. The session layer is also part of the TCP/IP model. The main functions of this session layer are the connection establishment, termination, and management. Layer 6. Presentation. The main purpose of the sixth layer is that it formats and encrypts data to be sent across the network, allowing everything to be compatible. Layer 7. This is the layer that is responsible for displaying data and graphics in a visual form that humans can interpret. That's the end of my presentation on network. Thanks for listening.